Hi dears, welcome to my channel. Here I am coming before you with a new lesson for class 9. That is lesson 4, structure of atoms. What was the third lesson? It was atoms and molecules. There I have asked you 3 questions, isn't it, ma'am? Now it's the time to answer these questions. The first question was atomic mass of sodium is 23. Simplest compound formed by two elements are called dash compounds. Simplest compound formed by two elements are called binary compounds. Valency of OH negative, OH minus is dash. It is 1, we can say minus 1, negative 1 charge it is having. Now we are moving for the fourth lesson, structure of atoms. Why we are saying the structure of atoms? Because we should know how the atoms are made, of what all subatomic particles are there in atoms. For knowing that, we are going to learn the structure of atoms. As the lesson is a little bit longer, I have made it into two parts, part A and part B. It doesn't mean that the lesson is so tough. It means that just for convenience for you to know it easily, I am making it into two parts. Okay, ma? It's very good to learn the structure of atoms. What did the Dalton said? Dalton said that atom was indivisible particle, inseparable. There is nothing inside the atom like that. In that manner, the Dalton has proposed. But the scientists have searched and found out that there are subatomic particles. That means atoms are divided into many things. There are some other things inside the atom. We are saying it as subatomic particles. For that, we have to congratulate J.J. Thomson, because he was the man. He was a scientist who discovered electron inside the atom. And Goldstein, he was the scientist, great scientist, who discovered proton, which is present inside the atom. We are saying that electrons are negatively charged particles, while protons are positively charged particles. So, for making the atom will be always in neutral state. Means how many negative particles are there, to that extent the positive particles should be there. That which makes the atom what? Stable, and it will be neutral. Okay, ma'am? Moreover, when we are comparing the weight or mass, electrons are negligibly smaller mass compared to protons. So we are not considering the mass of electron while we are considering the mass of atom. We are considering the mass of proton, but we are not considering the mass of electron. Okay. Now the scientist was searching to find how the electrons and the protons are arranged inside the atom. Okay, ma? For that, many scientists have searched and many higher scientists have gone for experiments. According to J.J. Thomson, what he was saying that electrons are just embedded in the proton sea. There is a sea of protons, and in that electrons are embedded. Here and there some electrons will be found. In that manner he was saying. For example, we can say in the form of, they are saying Christmas pudding, or we can say in our words as watermelon. When we are cutting the watermelon into two, we can see a red color sea. We are saying it as sea of protons. In the case of atoms, I am saying, okay, ma? Then black color seeds can be seen, right? It is considered to be electrons. So in the sea of protons, electrons are embedded here and there. And many scientists are not ready to accept it. And accordingly, Rutherford was a scientist. He also tried to find how is there any other shape for the atoms in atoms. Okay, ma? Thomson said that when the electrons are embedded in the sea of protons, amount of protons and electrons are same, and which makes the atom neutral. Actually, the atom is neutral, or atom is stable also, but we can't say that it is in this form. So Rutherford did experiment. How he has done the experiment? He took a small gold foil. Why he have selected the gold foil? Is anyone can say the answer? I will say because the gold is malleable in nature. While we were discussing the metals, we found that gold is malleable in nature because it can be beaten into so thin sheet in such a manner that it will be even transparent to see. In that manner, we can stretch or we can beat the gold. That's why he has selected the gold foil. And alpha particles, highly charged alpha particles, which are positively charged alpha particles, are allowed to pass through this gold foil. And how much alpha particles can reach the end? He just so the alpha particles are allowed to move through the gold foil, and in the opposite side, he was seeing how much alpha particles are moving or are hitting the other side. He found many alpha particles, much more alpha particles had gone through this foil in a straight line. Some alpha particles have deflected or deviated from the path in small angles. One among 12,000 alpha particle has rebounded back. Okay, three things has been happened. Most of the alpha particles went in straight line. Some of the alpha particles get deflected from the path, while 1 in 12,000 alpha particle get bounced back. So he found something is there inside the atom, isn't it? We can consider it as a playground. Okay, ma? Just to make you to know it in our manner. Okay, ma? We are not scientists now, so in our fashion we are saying we will be able to learn. We are considering it as a playground. Okay. There is a deep pit at the center. Consider there is a deep pit in the center, and we are allowing the children to run. Okay, we are allowing the children to run. Those who are at the end will run fastly, isn't it? Or those who are in both the sides will run so fastly without seeing, and there is no pit, they can't even see. Those who are going near the pit, okay, those who are near the pit, coming near the pit, they can see, oh, pit is there, I have to move. Okay, so they will deviate from their paths, isn't it? If one or two children are unlucky fellows, they may be coming straight in the path of the pit. So what they can do? They will be coming back. Or when they are seeing the pit, they will take a U-turn and they will come back in some other direction. They can move. Like this, it will come back, isn't it? In the same manner, the thing is moving. What he concluded is, from this experiment, Rutherford concluded many things. As the alpha particles are moving, much more alpha particles are moving in the straight line, he understood that most of the parts in the atom are empty. And the second one, when some of the alpha particles are deviated from the path, it means that he concluded that all the positive charges are concentrated in a particular point, a particular part. And the third one, when the alpha particles bounce back in 180 degree, what did he concluded that is not only the charge, all the mass has been concentrated at their particular point and a particular place, and it is not much big in the atom. It is considered to be in a small part. The volume of this part is very small compared to the atom. He is saying this as nucleus. In this nucleus, all the protons are concentrated, and most of the mass of the atom is concentrated in this nucleus. He concluded that. And what about the electrons? The electrons are orbiting, they are circulating this nucleus. It was his conclusion. Electrons are circulating in a circular path in the nucleus. In the nucleus, the electrons will be there outside the nucleus, and they are circulating the nucleus in a circular path. It is just like the sun and the planets. Sun at the center, like that nucleus in the atom at the center. The planets are revolving around the sun, isn't it? In the circular path. In the same manner, the electrons are revolving around the nucleus. This was his theory. And it was a big acceptable one, and it was almost correct. But he also had some drawbacks. Actually, everything will be having this force of attraction towards itself. As the electrons are revolving around the nucleus, there will be force. The nucleus will be trying to pull the electrons. Eventually, circulating, it will come directly to the nucleus and it will jump in the nucleus. Is it happening in the atom? If it is happening in the atom will be unstable. But the atom is not at all unstable. It's quite stable. So this thing is not happening. So there are some limitations. To overcome this limitation, Niels Bohr had some discoveries and he found some postulates. That is, nucleus is, as we said, nucleus is there. All the mass and positive charge is concentrated in this nucleus. And the electrons are revolving around the nucleus in circular path. He is saying it as energy levels. Because this orbit, he is saying it as orbit, and the orbits are having particular energy level. Electrons which are revolving in these orbits are having their own energy, and they will not give this energy at all as long as they are revolving in this orbit. So the thing is clear. And this is the structure of atom. Okay, ma? Now we have said this. This positive charge is there, electron is there. There is yet another part, subatomic particle is there. Other than electron and proton, some other electronic subatomic particle is called neutron. It's the one which is neutral. Why it is called neutron? Because it's not having charge. It is neutral in nature. But it is having mass same as that of proton. So, where it will be found? It is found inside the nucleus. So, nucleus is composed of what all things, ma? Protons as well as neutrons. And where the electrons are, ma? The electrons are revolving around the nucleus. This is the structure of atom. Okay. Why should we learn this is the structure of atom, ma? Why these things we should learn? Because if we are learning the structure of atom, it helps us to know the chemical reaction as well as the bonds, how the electrons are, how the atom is making bond or elements are making bond. For knowing that, and moreover to learn the physical properties of these, the structure of atom is very helpful. That's why we have to learn the structure of atom. Okay, if such a question is there in your mind, this is the answer. If anyone is asking in this manner also, in higher classes also, if you are knowing about it, it will be helpful. Okay, ma'am? Now, as I told you, the electrons are having discrete energy levels as they are revolving in this orbit. How many orbits are there, you know? We are saying this orbit as shells also. Shells or orbits. The orbits are having energy levels also. Now, how the electrons can revolve in this orbit only in the ordered fashion. One electron is saying, I like to orbit in this outside level. Is it possible? No, it's not possible because there are discrete energy levels and the electrons are able to fill in the higher energy level only when this lower energy level is filled. Okay. We are saying this first orbit as n. This is the energy level n. N is equal to 1. This n is equal to 2. And this n is equal to 3. One more shell is there where n is equal to 4. 4 shells. We are saying it as K, L, M and N. How many shells, ma? K shell, M, N and N. K, L, M and N. These are the 4 shells. How much electrons can be arranged in these shells, you know? There is a formula, that is 2n square. 2n raised having n value what ma? 1. So electrons, number of electrons it can occupy is 2 into K shell. Electrons are 2 into 1 raised to 2. What is 1 raised to 2? 1 raised to 2 is 1. 1 into 2 is equal to 2. So first 2 electrons can occupy in this K shell. Okay. What about L shell? L shell. 2 into 2 raised to 2. What is 2 raised to 2? 2 raised to 2 is 4. Into 2 will be 8. 8 electrons can occupy. Like that it is moving. So K shell can occupy 2 electrons. L shell can occupy 8 electrons. M shell can occupy 18 electrons. And N shell can occupy 32 electrons. In that manner, now we are saying about the electronic distribution, right ma? As I told you, the electrons are arranged in energy levels. Maximum number of electrons in each shell or each energy level or each orbit is in the order of 2 into n raised to 2 or 2n square. I told you how it has to be found. N is equal to 1 means K shell, 2 L shell, then n equal to 3 M shell and n equal to 4 N shell. In that manner, how the electrons are arranged is first shell should have 2 electrons, second shell should have 8 electrons and the third shell 18 and the fourth shell 32. In that manner it is. Second one, maximum number of electrons accommodate in the outermost orbit is 8. Means outermost orbit should have 8 electrons. When the outermost orbit is having 8 electrons, we are considering the elements up to 20. So it will be, we can say, otherwise also 8 electrons if the outermost shell is having, we are saying that the atom is stable. Okay. Then the third one is step filled. The electrons are filled in stepwise manner. The electrons are filled in step by step. Okay. So first 2 electrons are there. First K shell should be filled and the third electron should go in L shell. Then only when the L shell is filled only M shell has to be filled. Okay. I have made it wrong. Electrons filled in stepwise manner. Should be filled in stepwise manner. So we are seeing about neon. How much electrons are there in neon? Where is the periodic table? See this? This is the periodic table. Here, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The atomic number is 10. So, which means number of proton is 10. So, how much electron also it will be? 10. Because if the atom is stable, number of proton and the number of electron should be same. That's why neon is having 10. So, nucleus one, center is nucleus and first orbit. 2 electrons it should have. And the second orbit, it should have 8 maximum number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So electrons are filled. 2 electrons in the K shell and 8 electrons in the L shell. So this atom is stable. Okay. Here we are considering sodium. Sodium, again we are saying, what about the sodium? It is having atomic number 11. So, how much shell it should have? One more shell should be there because L shell is fully filled. Then we are moving for M shell. M shell is having 1 electron. Then only here 10 together 10. Then 1 more electron in the N shell, M shell. Okay, ma? So, is the sodium atom stable? No, because every atom will be having to occupy the octet configuration. That is, outermost shell should have 8 electrons. This electron is extra. Or we can say in two manner. Either this electron has to move away or there should be 7 more electrons to be added to make it stable. Which is better? to move away or to leave one electron is the better one, isn't it? So what happens? Sodium will try. Sodium has to be written like this. Okay. Sodium will try to leave this electron to make itself stable. When it is leaving one electron, the sodium atom will be changed into sodium ion, that is Na+. Why plus? The reason is electron, as I told you, number of protons should be equal to number of electrons. If one electron is pushed away, what will happen? One proton will be shown. It is not having pair, right? Twin, isn't it? 11 protons are there, ma. 11 electrons were there. Make the atom neutral. One electron had gone. So what happened? One proton is there extra. 11 protons and 10 electrons has been there. So one proton is extra. So make this Na plus ion it has become. Okay, ma? So why this kind of combining capacity? So what happens? Sodium will lose electron and it will be accepted by some other things and makes the atoms to bond with some other atoms. Makes this is called what? Combining capacity. Combining capacity will be formed because of when we are knowing the structure of atom, we will be coming to know the combining capacities of the atoms present in these elements. Okay, ma? Similarly, chlorine. If we are considering chlorine, Cl. Chlorine is having atomic number 17. What is the atomic number? Atomic number of chlorine is 17. Which means what? Which means it is having 1, 2, 3, 4, 5, 6, 7. 7 electrons. It has to either accept one electron or to lose these 7 electrons. What will it do? It will accept one electron. Okay. So the chlorine is having the tendency to accept an electron and to make itself as Cl minus. Why minus? One electron is coming from outside. But the proton is still 17. Electron has been changed to 18. Did you get, ma? That's why it is called Cl minus. It has been changed to ion. Thus, valency is the tendency of the elements for losing or gaining of this electron. We are saying it as valency. The rest of all can be seen in part B.